Dr. R.K. Radha, Assistant Professor, Department of Statistics, Presidency College, Chennai. She has done her PhD in statistics on a novel approach for prior selection in Bayesian modeling. She has 27 years of teaching experience, has guided 4 MPhil students, published 5 articles in national and international journals, has attended 10 conferences in India. She had given training for staff at Tamil Nadu State Statistical Training Institute, Department of Economics and Statistics.
Welcome to UGC lecture series on mathematical sciences. Under statistical inference, we are going to discuss about non-parametric tests. Few tests we have already discussed in earlier classes. Today some more we are going to discuss, namely run test for randomness, median test and Wilcoxon-Mann-Whitney test. Let us discuss what is run test for randomness. Run test is used for examining whether or not a set of observations constitute a random sample from an infinite population. Also, test for randomness is of major importance because of the assumption of randomness underlies in statistical inference. In addition, tests for randomness are important for time series analysis. Also, departure from randomness can take many forms. So, here we are going to discuss about the hypothesis to be considered for the random test using run. So, here we are going to take our hypothesis H naught, that is our null hypothesis, that sample values come from a random sequence against the alternative H1 such that sample values come from a non-random sequence. So, what will be the test statistic? Let R be the number of runs. Already we have discussed what is a run. So, run is a sequence of signs of same kind bounded by signs of the other kind. For finding the number of runs, the observations are listed in the order of occurrence. So, here next each observation is denoted by a plus sign if it is more than the previous observation and by a negative sign if it is less than the previous observation. Next, we take the total number of runs up and down is counted. Too few runs indicate that the sequence is not random, has persistency, and too many runs also indicate that the sequence is not random. It means that it is in zigzag position. So, next is critical value. The critical value for test is obtained from the table for a given value of n and at the desired level of significance, namely alpha. We are going to denote this critical value as RC. What is the decision has to be taken depending upon the table value obtained from the run test. That is, if RC lower value is less than or equal to R of less than or equal to RC upper, we have to accept the hypothesis, otherwise we have to reject the hypothesis. So, let us discuss this through an example. So, given a sequence, we have to check whether the sequence is random. So, these are the observations, namely about from 5.2 to 7.5 the observations are given, nearly about 10 observations are given. So, as we have stated in the run test, we have to check the randomness using the run. So, H naught is such that the sample values come from a random sequence. Alternative, we are going to take that the sample values come from a non-random sequence. Now, the problem is we have to find out the number of runs. So, given problem is being taken as it is. Now, I have said that for this how the run is being calculated is that take the first value 5.2, now take the second value 5.5, compare 5.2 with the 5.5. You find that 5.5 is greater than 5.2, so put a plus sign. Now, come to the second value, third value 3.8. So, when you come to 3.8, compare it with the previous value 5.5. So, you find that 3.8 is lesser compared to the 5.5, hence denoted by a minus sign. Now, take for the fourth value 2.5, this is completely lesser compared to the previous value. So minus sign. So doing the operations in this manner, come to the value 10. When you come to 1.7 and you compare with the 10, this 10 is greater, so you put a plus sign. Whereas now the next value is also 10. When you compare, you find that there is no increase or decrease, but the difference is 0. So you put it as 0. The next value is 6.9, which seems to be lesser, so minus sign. So repeat the procedure. Now total number of observations, if you take here, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now this has been reduced to 11 observations because one of the observation is 0, hence the observations get reduced to 11. Now we have to find out how many number of runs we have got. So here when you take here, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, so 7. So totally you have got 7 runs. So like sign will be bounded by the other sign. That is the concept for the run. So you have got number of runs is equal to 7. Now you have to find out the critical n values for alpha at 5% level. Here our hypothesis is that we have to check whether there is a random in the sequence, alternative there is not. So it is a two-sided test. Now using the run test table, you will find that RC, that is a critical value, for the lower is 4 and for the upper value it is 10. Therefore you find that R will lie between 4 and 10, your value. So here the number of runs is 7. You find that 7 comes in between 10. So it is in the proper order. Hence your H0 is accepted. Therefore the sequence is random. So next let us move to the next test, namely the median test for 2 samples. So here we have to check whether or not 2 samples come from the same population. So median test is used. So this test is more efficient than the run test, and you have to have the sample size of 10 at least. In this case, the hypothesis to be tested is that hypothesis is H0 is such that the sample come from the population having the same distribution. So H1 is nothing but the samples come from the population having a different distributions. So here you need 2 samples for the comparison. So what will be the test statistic? Test statistic is going to be the chi-squared. So to test the value of the test statistic, 2 samples of N1 and N2 are combined. Next we have to find out the median M of the combined sample of size N is equal to N1 plus N2 is obtained. So combined sample, in the sense that how do you obtain the median, is that given sample has to be arranged in either increasing or decreasing order. Find out the middle value, that will be the median. So you will be getting your M. And you have to note the number of observations which are below and above the median for each sample. This is nothing but a 2 by 2 contingency table which is given below. So here the table can be thought like that. Number of observations, you have sample 1 and sample 2. So take the first sample, find out the value above, how many values are above median denoted by A. Come to sample 2, find out how many values are above the median value denoted as B. So this is the total A plus B. Come to the next row below median. So you fix your M, find out those values which are below that denoted as C for sample 1 and D for the sample 2. Find out the total C plus 2. Now complete the table of rows and columns. So you will have A plus B, A plus D, A plus C and B plus D, giving out the total number of observation as N. So this seems to be nothing but your 2 by 2 contingency table in the case of chi-squared. So, the test statistics is going to be here A plus B plus C plus D, which is nothing but my capital N, into, if my observations are A, B, C, D, so you cross multiply AD minus of BC, square it out, divided by sum of the rows A plus B, C plus D, sum of the columns A plus C and B plus D. So, come to the decision rule. If the calculated value is greater than or equal to the critical value, that is the table value, reject it, otherwise you accept the hypothesis. Ties are ignored and n is adjusted accordingly. So, here come to an important note that here we have taken only for 2 samples. You can extend it to the k samples with the number of observations below and above, and you can find out the combined mean from a 2 by k contingency table, that is 2 rows with k columns you can have. Now, let us understand this concept through an example. So, here the example we will discuss to determine if a new hybrid seeding produces a bushier flowering plant. The following data was collected. You have to perform a median test for testing that the 2 samples come from the same population. So, here a new hybrid is given to you and the current variety is given, one is denoted as X and the other one is denoted as Y. So, what is your hypothesis? Hypothesis is going to be H naught is such that the 2 populations are identical. I said that in median test we are worried about that where it comes, whether it has got the same distribution or not. So, H1 is going to be there is some difference in the girth of X and Y shrubs. Now, we are going to combine the data, that is this data we are going to combine it out and we are going to arrange it out and write it out. So, when you arrange the combined data seems to be 21.3, 24.8, 25, 27.6. So, you arrange this here, that is you have found out your median as 32.8. So, median 32.8. So, here 32.8 means it is going to be here. So, I have taken it as X, and here similarly if it is for the other set you denote it as Y. So, combine and arrange it out so that you will have the like symbols and the unlike symbols together. Now, you know that after arranging the data median value is 32.8. Now, the problem lies in finding out how many observations are above and how many observations are below the sample. So, when you take the number of observations above and first let us fix it for X value. So, when you take the X values above 32.8, how many values are there? You will have here 1 and here it is 2, here it is 3 and here it is 4. So, above X you have got 4 values. Come to the values of Y. So, here above 32.8 when you take here this is the first value and here this is the second value. So, you have got 2 values for Y. Now, we have to find out for X what are the values which are lesser than 32.8. So, here when you come to X lesser, here it is 1, again here 2, and here when you come to the thing no other values. So, here below X 32.8 is 2 observations. Again come to Y. For Y what are the values which are lesser than 32.8. So, here you have got 1, 2, 3 and of course, this value. So, you have got totally 4 values. Now, add up the row total and the column total. So, you have filled in the tabular column. Now, you have to do the calculated value. So, here this is your capital N. So, here I have said chi squared is equal to N into AD minus BC the whole square divided by sum of the rows and the sum of the columns. So, here you find observations are 4, 2, 2, 4. So, this will be 16 minus of 4, sum of the rows is 6, again here 6, sum of the columns is also 6. So, when you take the total sum of observations, n is equal to 12. So, you have got n into AD minus BC the whole square divided by sum of the rows, 2 rows you have got, sum of the 2 columns. So, you are getting your calculated value as 1.33. Now, you have to compare this calculated value with the table value. So, table value you have got 2 rows and 2 columns. So, here 2.384 is your table value. When you look into the chi-squared for chi-squared with n minus 1 into m minus 1, where your n is nothing but the number of columns, m is going to be number of rows. Here 2 rows and 2 columns, which will give you 1 degrees of freedom. So, chi-squared 1 degrees of freedom at 5% level. So, here you have got that 2.384 H naught is accepted. Therefore, we conclude that 2 samples come from the same populations. That is, there is no significant difference in the girth of the hybrid and current variety of shrub. Let us move to the last test, namely Mann-Whitney-Wilcoxon's test. So, this Mann-Whitney-U test is a non-parametric alternative test to the independent sample t-test. So, t-test is used to test the difference in mean. We are very much familiar. Alternative to that, it is used. So, here it is used to compare 2 sample means that come from the same population, that is to test whether 2 sample means are equal or not. Usually, the Mann-Whitney-U test is used when the data is ordinal or when the assumptions of t-test are not met. So, this is very important point which we have to note. Sometimes understanding the Mann-Whitney-U test is difficult to interpret because the results are presented in a group rank differences rather than group mean differences. So, assumptions. So, being a non-parametric test, it does not assume any assumptions related to the distribution of the scores. However, there are certain assumptions which are to be assumed. So, first assumption is that the samples drawn from the population is random. Second point is that independence within the samples and mutual independence is assumed. And third point is that means that an observation is in one group or the other, that is the whatever value you have taken, that value will be either in the first sample or the second sample, but it will not be in both. Ordinal measurement scale is assumed. Next, what is the test statistics? So, test statistic is given as U is equal to n1 n2 plus nx into nx plus 1 by 2 minus r. So, here n1 is the size of the first sample, n2 is the size of the second sample, and r is the larger rank total. Before that, you have to know what is nx. Nx is going to be that you have to find out the rank of the first sample, find out the rank of the second sample, get the sum of the ranks, find which sample has got the sum greater, that will be your R, larger rank total. For that, you have to find out the sample size, which is denoted as nx. So, corresponding to R, you will have your nx, that is nx will be the sample size of the larger rank total. Now, come to the critical value. The critical value of U is obtained from the tables of Mann-Whitney-U test. So, the tables are available for two-sided and one-sided, namely for 5% and 1%. You can make use of the tables and you can find out your critical value. Now, let us go for this example how to go about this problem. So here given two brands, given the ratings of two brands of the products, use Mann-Whitney test to test whether there is significant difference between the ratings given to each brand. So you have got two brands. So here separate rating is given for brand X. So 6 persons have participated, they have given their ratings for brand X. Similarly, another 6 participant is there and they have given their own ratings for the brand Y. So rating is given on basis of a 10-point scale. Okay, so they have given the points from 1 to 10, based upon that the rating is being given. Now our problem is that we have to make use of a Mann-Whitney test to test whether there is a significant difference between the ratings given to the each brand. So here we will go in step by step procedure. The first part is that you have to rank the scores together, ignoring the group which they belong to. So here for brand X, I have got the participant, corresponding to that rating is given. Again for brand Y, participant is there, rating is given to you. Now I have to rank. So how to rank? So I will keep the ratings as such instead of combining. See here, to start with, give the first number 1 is not there, so 2 is there. When you come to 2, you find that 2 values are there. So how to give the values? So here 2 values means 1 and 2. So here I cannot give at a time 1 and 2. If it is same value, you know by definition of rank that you have to add their rank position 1 and 2 divided by 2, being a 2 observations. So you will have 1.5 and 1.5. So here 1 and 2 gets over. So 1 and 2. Next I have to go for the next value 3. So 3 is here, check whether any 3 is there in brand Y. So 3, for that the rank is 3. Similarly, go for the next observation, rating 4, 4. Then here 4 is not there in brand Y. Next observation 5, you find that for in brand X there is 1 5 and in brand Y another 5 is there. So here how to give the observation? So you have given the values up to 4, given the ranks up to 4. Now there are 2 observations, so this has to be either 5 or 6, this again has to be 5 or 6. So 2 observation, add them, 5 plus 6 is 11, divided by 2 you will get 5.5. So you assign the rank 5.5. So after 5, come to the next observation 6. So when you come to 6, you find that for brand X there is 1 6 and the other 6. Already 5 and 6 you have assigned. So here it is going to be 6 and 7. Okay. So here when you come to this 6 and 7, sorry 7 and 8, because here you have given 5 and 6 for the 5. 5 and 6 you have given for 5. Therefore here it has to be 7 and 8, 7 and 8. So you, as before, you take the average. 7 plus 8 is going to be 15 divided by 2, 7.5 and 7.5. Next, what is the observation left out? 8. Okay. So when you come to the observation 8, 7 and 8 is there. So here after 6 you have got 1 7. So 7, 8 is gone. So you will have 9. Now come to 8. 8 will take the rank 10, and here last observation is after 8 9, give the rank 11, and 10 is the last rank which gives you 12. So totally 12 observations combining brand X and brand Y ratings, you have assigned the rank. Now find out the sum of the brand X rank. So it is 23. Find out brand Y rank, sum is 55. Now for the first sample, N1 is 6, N2 is 6. Then you have got brand X total, I will take it as T1. T1 total is 23. Here for brand Y, total is 55. So, which is greater for you? 55 is greater, therefore, my Tx is going to be 55. So, here for T2 brand Y, sum is 55 greater compared to T1. What is the sample size of this? Sample size of this is 6. So, Nx is equal to 6. So, I know now my N1, N2, my Tx and Nx. Now, I can calculate what is my U statistics. So, U statistics is given as N1 into N2 plus Nx into Nx plus 1 divided by 2 minus of Tx. The Tx is nothing but, which I have denoted it as R. So, what is N1? N1 is 6, N2 is 6, my Nx is 6, here Nx plus 1 becomes 7 by 2 minus my R is going to be 55. So, 2 goes 3 times, here you will have 36 plus 21 minus 55. Therefore, your total of U is nothing but 57 minus 55, which is equal to 2. Now, I have found out what is my calculated value. I have to find out what is my critical value. So, critical value you have to find out for N1 and N2. N1 is 6, N2 is 6. So, here when you refer the Mann-Whitney U tables, you find that N1 6, N2 6, value at 5%. Your two-tailed test is nothing but U value, critical value is nothing but it is 5. Similarly, for N1 is equal to 6, N2 is equal to 6 at 1% level. When you refer the Mann-Whitney table, you will find that U is equal to 2. Now, I have to compare my result. How do we compare? We compare the U statistic value with the U critical value. So, whether it is greater or lesser, we have to compare. Now, here when you compare, see here you find that the calculated value is 2 and the critical value is also 2. It means that it is 2 is equal to 2 at the case for 1% two-sided test. Two-sided test for 6 degrees of freedom. So, what is the inference you will come across? So, in this case you find that here see it is 2 is equal to 2. If it is lesser than, we try to say that we reject the hypothesis. So, here in this case we say that it is highly significant. Okay, in this case it is going to be highly significant at 1% level. When you take at U is equal to 5, you find that still you will have that 2 is lesser than 5 value. So, in 5% case also you will find that the calculated value is lesser than the table value. Therefore, it is going to be highly significant. So, when it is highly significant, what is the conclusions you can try to draw? So, you can give the thing that buying the product based upon brand X and brand Y. So, you say that there is a highly significant difference between the ratings for the brand X and brand Y. So, this concludes your Mann-Whitney U test, making use of your test statistic. Now, let us sum up what we have done in today's class. So, we have discussed the run test for randomness. So, you know that the run test is used to check whether that the set of observations constitutes a random sample from an infinite population. When you take the median test, the purpose is to test whether or not two samples come from the same population. Next is Mann-Whitney U test. So, here when the data is ordinal or when the assumptions of the t test are not met, we make use of the Mann-Whitney U test. Now, I have got few questions to be answered. You have to explain a run test for randomness, median test. So, in such a case, for run test for randomness, state what is the test statistic and critical value, how do you compare and draw the inference. In median test, we have to discuss about the two samples, then you are going to assign the ranks and you are going to do it out. So, when you come to the Mann-Whitney test, here you make use of your ranks. Depending upon the ranks, you find out one which has got the higher ranks and draw the conclusions. So, thank you.